Hello and welcome to the Computing Conversations column. This column is from the August 2014 issue of IEEE Computer and is titled Elizabeth Fong, Creating the SQL Database Standards. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column and I'm Charles Severance from the University of Michigan. The rotating mass storage that enabled random access to large amounts of data is one of the key technologies that helped computing evolve from long-running batch processes to something more in the moment and interactive. However, these mass storage devices were limited by seek time and rotational latency, so computer scientists and vendors spent decades optimizing how applications could be best utilizing them. My first database application back in the early 1980s was on a dual floppy IBM PC, with the database software in my application on one floppy disk and the data itself on another. You could actually hear the seek time and rotational delay in the action as the application executed. By the end of the 1980s, the market for database management systems was starting to mature and converge around the structured query language that we still use today to develop database applications. I spoke with Elizabeth Fong of the National Institute of Standards and Technology about the early standardization efforts around SQL. In the late 1970s, companies like IBM and Oracle were building increasingly sophisticated database management engines. Everyone wanted to maximize the performance of the applications built on top of these proprietary systems.
And we call it the file system. The files were hierarchical. There was the IMS, the IBM Information Management System, which is a tree structure. And the debate was going on whether there should be a tree or a network or flat file. And we are still debating whether the data have a self-describing tag, and later on we known it as a metadata, and now people call it the schema.
The U.S. federal government was a large consumer of these expensive and proprietary technologies. To help make sense of the emerging market in the late 1970s, the National Bureau of Standards, NBS, which is now NIST, was charged with building consensus around common approaches to simplify procurements.
And there were products that are growing from wild. And then we realized that, hey, I want to buy a product. What kind of a feature do I need? Another one of the things that I have done is the feature analysis. So we have about half a dozen of products, and the standardization are really building a consensus.
NBS wasn't allowed to simply make the standard by fiat. The standard needed to emerge from a consensus process that involved representatives from technology industry as well as end users who would be purchasing the systems. It could neither lead the effort nor force participation in the process, but with the promise that government procurements would someday require compliance to the standard, there was broad interest in participation. The first working group simply tried to come up with a sensible model and some terminology to lay the foundation for later technical standards.
The database system study group come up with a reference model or specification for a minimal functionality of a database management system. In order to be a database management system, you want to be able to store data, retrieve data, modify data, organize data, and it becomes a spec.
The next step was to begin the actual development of technical specifications in the American National Standards Institute. ANSI develops proposed specifications and represents the U.S. in the International Standards for Organization, ISO process. The overall goal was ultimately to produce an ISO standard, but the technical work started in the ANSI organization.
We initiated a birth of an ANSI group. It's now called NSIDE. The ANSI is American National Standards Group, and it's called the X3H2. Don Deutsch and people like Lang Gallagher all participated in that. That group is called the Data Management Language.
The group focused on the development of a language to communicate between an application and the database management system.
In order to standardize anything, the only thing you want to standardize is when you want to talk to another person, a communication interface, or a area where both of us have to understand a common vocabulary or whatever. The only standardization of a software system is not the capability, but the language.
While some in the early 1980s were still debating the best model for data storage and retrieval, the relational model was starting to represent the broadest consensus in the marketplace.
And relational database at that time was IBM, Chris State, and he's talking about normalization. He started talking about flat file, and he called it a table, and it's a very easy concept that everybody understands. So in order to retrieve a table, you say select from a column such and such, from a table of employee, and there was a birth of a simple query language.
By the late 1980s, the ANSI X3H2 committee had completed and published the first SQL specification. The standard specified the syntax and semantics of two database languages, a schema language definition language and a data manipulation language. While the language was simple and straightforward, it took a significant amount of research and development to build highly optimized database management system implementations to support the relational model. Once standards were in place and the industry was providing relational database management systems, NIST, which by now had been renamed in 1988, turned its focus to building test suites and certification processes for products claiming to comply with the new standards.
Testing part is also a very important aspect of when you adopt the standard. You want to certify that the product conform to such and such version of ISO standard, JTC1, whatever it is.
Even though NIST was an important force in creating SQL standards and the conformance testing processes around those standards, it leaves all final decisions regarding purchases to the government agencies doing the procurements.
I mean, this is strictly user. You're buying because you're paying the money, not us.
I asked Fong why the SQL standard turned out to be so successful and continues to be so relevant.
Timing is everything. You can't standardize a thing too early, or you drive a lot of innovative concept away because people say, hey, there's no way for me to get into your market because you already decided, and even though it's not very good, I won't get into that business. So you killed innovation. And if it is too late, you miss the opportunity. You get too many variety of things coming up, and the choice is too much. But of course, SQL is one of the success stories that NIST we have.
SQL brought the right standard forward at the right time. Its initial development took over 10 years, during which the standards process was both informed by and contributed to research and development efforts. Companies also had enough time to adjust their strategies and embrace the relational approach before the standard was finalized. Today, we greatly benefit from the visionary leadership of NIST and those involved in the ANSI X3H2 effort all those years ago. This column is from the August 2014 issue of IEEE Computer and is titled Elizabeth Fong, Creating the SQL Database Standards. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.